So whenever we have a function, we have a curve. Let's say this is a curve of y is equal to f of x. And we have this point. Let's say at this point, we know the value of the function. Let's call this point a. And at this point, the value of the function is f of a. Now, this value is known. At a, the value of the function is f of a. We know this value, but we are interested in finding out the value of the function at a nearby point, at this point. Okay, so which is like, 0.1 or 0.2 units above a. So what we do is, instead of finding out f of this point, we make a tangent at this point. We say, instead of finding out the value of the function at the curve, which at the curve it will be this value, but we will find out the value at the tangent. So if a point is, this yellow point should be very close to this red point, then only this approximation works. Because if you take a point which is very far, then this tangent will give you a different value. So if you take a point which is very far, somewhere here, and then if we use tangent line approximation, then we will get different answers. But right now, this point will get same value, approximately same value.
Does linearization always use a graph?
No, you don't have to use a graph, but this is what goes behind the scenes.
Okay, makes sense.
Okay, so just in case if you forget the formula, then you can always find out the formula. So if you try to write the equation of this tangent line, the equation of the line in 2-point form is y minus y1 equals m times x minus x1.
Yes.
So on this line, and now our function is no longer f of x, but it is L of x.
Okay.
So we say L of x minus y1. Now this point this point is a comma f of a. So we are assuming that this point lies on the tangent. So we say minus f of a is equal to m. M is f prime of a. M is the slope of the tangent line at point A. So f prime of a times x minus a.
Okay.
So from here we get L of x equals f of a plus f prime a times x minus a. Okay. Now the problems that we get are the problems in which sometimes this function f of x will be given to us, sometimes it will not be given to us, and we will have to come up with this function on our own. So let's say the function is f of x equals square root of x. Okay, and we want to estimate f of 37. We want to find out what will be the value of f of 37. That means we want to find out what will be square root of 37.
Okay.
Now, whenever you get these questions based on linearization, we need to find out what is a. A will be that x value at which we know the value of the function. Like we can easily find out value of the function at a. So, and it has to be very close to 37.
Okay.
Okay. So can you think of a point which is very close to 37 and you can find out its square root easily?
36.
36. So that will be our a.
Okay.
So a is 36 because we can find out f of a very easily. So f of a, which will be, f of 36, which will be square root of 36. So that is 6. So we have a, we have f of a in this formula. We have f of a, we know what is a. Now we need to find out f prime of a. So first you can find out f prime of x. Square root of x, its derivative.
The derivative of square root of x would be 1/2 x raised to minus 1/2. Okay.
So f prime of a will be 1/2. A is 36. 36 raised to negative 1/2. So we can write this as 1/2 times 1 over 36 raised to 1 half. So 1 half times 36 raised to 1 half, that means square root of 36, which is just 6. So this is 1 over 12. So now we have all the values.
Okay.
We know A, we know f of A, and we know f prime of A. So we can put everything into the formula. So L of x. Now instead of saying L of x, we can say L of 37. So that will be f of A, so f of 36 plus f prime of 36 times x minus A 36. Okay.
Okay.
Okay, right now this is just L of x. We will find out the linear function. Now f of 36 is 6.
Mm-hmm.
F prime of 36 is 1 over 12. And this is just x minus 36. So 6 plus 1 over 12 times x minus 1 over 12
3?
times 36, 3. So this
Okay.
is 6 minus 3, 3. So 3 plus 1 half of x. This is the linearization of square root of x at a is equal to 36. Now we can put 37 here. L of 37. So 3
Mm-hmm.
plus 1 over 12 times 37.
Okay. Give me 1 second. I'm just writing that down.
Yeah, of course.
Okay.
Okay, so 37 over 12 will be 3.08333 repeating. And then
Mm-hmm.
this will be 6.0833.
Okay. 3 plus 3. Okay. Got it.
So that means square root of 37 is approximately 6.0833, and which makes sense because we know that square root of 36 is 6. So square root of 37 will be, just slightly greater than 6. But this will work only for a point which is very close to 36.
Yes.
Okay.
Got it.
Okay. Again, let's do one more problem in which function is known. So f of x is x cube, and we need to estimate the value of what will be 2.1 cube.
2.1 cube?
Hmm.
Okay.
So what will be a?
Maybe A has to be the number that's like the approximation, right?
No, a has to be a number which is very close to
Yeah. Sorry,
this.
that's what I meant.
Okay.
So maybe 4? But that's
4,
too far, right?
no, yes, 4 will be very far from 2.1. We need a number which is very close to 2.1, and we can find out f of that number easily. F of a, we can find
Oh,
out.
would 2.5 work?
2.5 will also be very far. You can try
Oh.
to think, still you can find out a number closer to 2.1.
Um,
And it doesn't have to be greater than 2.1.
oh, it doesn't have to be greater?
No,
Oh, okay. And you have to be able to take the square root, no?
not square root. Now this time your function is x cube.
Oh,
So you just have to be able to find out its cube. That's it.
oh. Um, I'm not sure.
So a number which is close to 2.1, whose cube can be found out easily. Cube is just a
I'm
times a
trying
times.
to remember all the cubes.
So you can just take 2.
Just 2?
Hmm.
Oh.
See, 2.1 is very close to 2. And you can easily find out f of 2.
Oh, not the cube root, the cube.
Yes, this function is x cube, right?
Oh, I was thinking of finding the cube root
Oh,
of something, and I was okay. I understand now. Okay.
okay. So f of a will be 8. And let's also find f prime of x. That will be 3x squared.
Mm-hmm.
So f prime of a will be 3 times 2 square, so 3 times 4, so 12. Now we can use our formula. L of x is equal to f of a plus f prime a times x minus a.
Mm-hmm.
So f of a is 8, f prime of a is 12. See, you already have this 8. 8 because if you do 2 cube, you get 8.
Mm-hmm.
And you'll get 8 point something. That point something will come from this term. It's 12 times
Oh.
x minus a is 2. So this is our linear function.
Mm-hmm.
Okay. Now put 2.1 here, L of 2.1. So, this is what? This is equation of the tangent line.
Uh-huh.
Tangent line passing through the point, passing through 2 comma 8.
Okay.
And since 2.1 is very close to 2, so the value of the function will be also very close to the value of this linear value of the tangent line at point 2.1. So 8 plus 12 times 2.1 minus 2. 8 plus 12 times 2.1 minus 2 will be 0.1.
Yes.
12 times 0.1 will be 1.2.
Mm-hmm.
Be 9.2.
9.2? Oh, 8 plus 1.2. Okay, understand.
And if we find out the actual value of 2.1, you can use, so if we use our calculator, let's see what is the actual value of 2.1 cube.
Okay.
Yes,
2.1 raised to 3.
9.261.
9.22. I'm just calculating it on my end just so I can, yeah, 9.261. Oh, okay.
Okay, so 9 point, that is a very good approximation.
Yes.
Okay.
Okay.
Now we will do a cube root problem.
Mm-hmm.
So now function is not given. It just says estimate cube root of 8.1. That's it.
8.1?
Hmm.
Okay. So then I guess, oh, we could just take 8. That's the easiest.
8?
Yeah.
Yes. So, and what will be the function? This time function is not given.
Oh. A equals 8, so f of x equals just cube root of x?
Yes, cube root of x.
Okay. All this noise.
Oh, I cannot hear anything.
Okay.
So f of 8 will be cube root of 8, which we know it's 2. Now f prime of a, f prime of x first.
Mm-hmm.
So 1 over 3 times x raised to negative 2/3.
Okay.
So f of 8 will be 1/3, 8 raised to negative 2/3. Oh. So that will be 1 over 3 times 1 over 8. So 1 over 3 times. And 8 raised to 2/3 will be 2 raised to 2, which will be 4. So again, 1 over 12. So now you can find out the function L of x, f of a plus f prime of a times x minus a.
Is it okay if I take 1 second to write all of that down?
Yes, sure.
Thank you. I was just busy watching you write it and understand it, and I forgot to write it.
Yes, no, absolutely.
Okay. 5 1/3 times 1/4. Okay, I got it.
Okay. So f of a we found that was 2 plus f prime of a is 1/12. Then x minus a, which is 8. Okay, you can leave it here and just find out L of 8.1. 2 plus 1/12 times 8.1 minus 8. So 2 plus 1/12 times 8.1 minus 8 will be 0.1. So 2 plus 1/12 times 0.1. This is 0.1 divided by 12. It is 0.0083 repeating. So this will be 2.0083 repeating. So this is cube root of 8.1.
Got it.
And the actual value, I was just using calculator, actual value of 8.1 cube is 2.00829885.
Okay. Yeah, I was going to look it up, but because you already did, I just did it.
Okay. Are you feeling confident in this now?
Yes, I think it's all right. I think I only said that because linearization and optimization, I remember talking a lot about them, so I think I thought it was one of the harder topics. I think I'm fine on this though.
Okay, I'll just write 2 problems for you. We don't have to solve it completely. You can just tell me what will be the value of A. So ln of 1.05, you have to estimate it, and what for tangent of 46 degrees, what will be the function and what will be A? Because rest of the part is easy.
Yes. Okay. So 1.05, and we have to estimate the tangent at 46 degrees? Okay.
These are 2 separate problems.
Oh, okay. For the first one, I think the function would just be ln of x, right?
Yes, ln of x.
Okay. And then I think a could be 1.
A could be 1 because we know ln of 1 is 0. So
yes,
A will be 1. Okay. And here?
There, the function would just be tangent of x.
Hmm.
And then a could just be 45 degrees.
Okay, good. Okay, then rest of the stuff you can do it on your own, right?
Yes.
Okay. So this is linearization.